Alright, welcome back here. Let's take a look now at negative tangent of 2x. Well, if we have negative, you're thinking about the parent function again, the tangent of x, right? So what's that negative in front of that going to do? You know, what does negative f of x do? Well, of course, we're thinking, well, that's going to reflect about your x-axis, right? In other words, what does negative f of x do, right? If your original function was tangent of x. And then what's this 2 going to do? Well, it's going to mess with our period again here, right? So why don't we think about this, our vertical asymptotes here, okay? So we got this negative sine of, 2x over cosine 2x, right? So we're just thinking to ourselves, well, where does this cosine of 2x, again, where's the cosine of 2x equals 0? And we say, well, I know the cosine of pi halves. I know the cosine of pi halves is 0, right? In other words, what x value will cause this to be true? So, I got to divide by 2 here, divide by 2, divide by 2. So we got pi fourths is our first one, right? And then whereas, now we know the next one is when that cosine 3 pi halves equals 0, right? So, well, where does 2x equal 3 pi halves? X equals 3 pi fourths, right? And then where's the next one going to occur? What's the difference between those? Well, the difference between pi fourths, 3 pi fourths, is 2 pi fourths. The next one's going to end up being at 5 pi fourths, and then 7 pi fourths, and so on, okay? So when you're drawing this thing, yeah, I'm going to put my first slash, instead of my first slash being at pi halves, well, we can put it on there just like the tangent function. You can see that that's a little bit skinnier here, if you will. Okay, so it's actually at pi fourths is this vertical asymptote, at pi fourths. And then at negative pi fourths, okay? So I'm just kind of getting a feel for this. And then instead of going increasing on this thing, we've reflected it, okay? So instead of that, we've reflected it about the x-axis, okay? So, oops, let me take that off here. So now it's going to be each of those points flip-flopped, okay? So more like that, okay? And then 3 by 4, so the next one's going to be like that. Okay, and so on. Alright? Anyways, approximately. Okay, so let's take a look at this thing with our calculator here. Go over to my desk. Okay, so I'm going to punch in, I actually have the tangent of x already in there. And then the other one is negative tangent 2x. Okay, and then we're going to go zoom trig. So each cut here, zoom trig, is pi halves. All right, so there's our original tangent function, right? Can you see how, oh, it's flipped over? And it's kind of like vertically stretched that thing. Of course, you got different vertical asymptotes. So that's what that 2 did. And the negative in front, of course, the reflection. In fact, let me just clear that one out. We'll just look at the negative tangent of 2x here. Okay? All right. Of course, your range there is going to be all real numbers, your domain, everything except those vertical asymptotes, and so on. Okay, let's look at this next one here. All right, how about some graphs of reciprocal functions? So let's say you have the cosecant of x. Now remember, run back over here real quick. The cosecant is 1 over the sine of x, right? So that's really what we're graphing right here. So you're going to have some undefined points here. Where does the sine of x, that denominator, where's this thing going to end up being 0? I say, well, it's 0, sine is 0, 0, right? Where else? Well, we know that the sine of pi is 0, right? So if x is pi, we know the sine of pi is 0. Next one, 2 pi, next one, 3 pi, and so on. Of course, we also have negative pi, so this is plus minus, negative 2 pi, and so on, okay? So if you're graphing this thing, we know it's undefined at 0. I'm going to have each of these be pi halves. Pi, 3 pi halves, 2 pi, okay, and so on. And then we just pick some points, right? So say, well, let's plug some points in now. So we're not going to plug in 0 because we know it's undefined there. How about the old pi halves, right? So 1 over the sine pi halves. Of course, our sine of pi halves there is 1. Halves comma 1, right? Plug in some other points. Take forever on this, but let's take a look at the graph here. Calculator. Okay. So the cosecant, so 1 divided by the sine of x. Okay. See those vertical asymptotes on there and so on. And we plugged in, let's go trace here. We plugged in pi halves, right? Oops, pi halves, we get the 1. We could have plugged in like pi fourths, right? We get 1.414 and so on. Okay. Anyway, so it's kind of some interesting behavior here. Now, you notice that this point approximately is a minimum, right? That minimum right there. Okay. And if you wanted, you could find the minimum. You go minimum, give me the relative minimum, go to the left of it, go to the right of it. Oh yeah, it really is that pi halves comma 1 that we had already found, right? That's the minimum point. Looks like over here we got 3 pi halves comma negative 1 is probably going to be our minimum over there. 3 pi halves. Oops. Negative 1, right? 4.712 comma negative 1. Let's check that, see if that really is our local maximum. It is 4.712 comma negative 1, right? And so on. Okay, so we have these hills and valleys type of deal. And the question also was, how does this thing compare to the sine of x, to its reciprocal function, right? How does the cosecant compare to the sine if we were to graph those? Take a look at both of those here. Notice your domain is everything except the vertical asymptotes again. Now there's the sine function. You see that? Notice where they meet. Okay, the relative maximum of the cosecant function is a relative minimum of the sine function. Okay, so the hill meets the valley, if you will. Okay, the valley meets the hill of the sine function, and so on. Okay, so it's kind of interesting there on those reciprocal functions. Let's do a different reciprocal function. Okay, put it up here. So how about, let me stop here and I'll do it on the next one.